Ducy. I work at a company called Sysdig. I've been in the DevOps world for a long time, helped co-organize DevOpsDays Columbus, DevOpsDays Minneapolis, and so forth. So let's define microservices. How many people use microservices or an architecture or moving that way? All right, fair number of you. So this is by Martin Fowler, and I think the important thing is there's no precise definition of microservices, but that definition makes things really, really confusing when you actually read that entire thing that Martin Fowler posted. Martin actually has a really good blog that actually breaks things down in much more simpler terms, and this is a good way, and this is kind of the more common way that we think of microservices, where you take a monolithic-based application and you break it down into smaller components, and then basically over the network, these components are able to talk to one another and do remote function calls and things like that. Now this sounds very similar to SOA, but it's not SOA, or service-oriented architectures. It is a service-oriented architecture, but it's not what we traditionally thought of when we looked at service-oriented architectures, and mainly because it takes into account a lot of innovations that we've had in the last several years. And one of those innovations is containers. So what are containers? So containers actually is a collection of things on a Linux operating system and now on Windows that makes it easy to isolate processes. So it uses things like cgroups, namespaces, LSMs, seccomp, and a whole bunch of other things. But what it is it's this ability for you to basically isolate how processes can interact with one another and interact with other systems as well. And now when we're moving towards this container type model, what we're actually looking at is how do we package up the application and the libraries and then provide a very generic kernel that the containers use to actually go and run their applications. This is just a picture. I needed another slide. I needed 20 slides, so I just threw a picture of my boss in there and his kid. If you ever do an Ignite, that's a little trick. So this makes you think about how you monitor these containers and the applications that are running inside of them and rethink it when you're looking at a microservices architecture. And these are the five, what we call at Sysdig, the 5 principles of modern monitoring. So monitor containers and what inside. So traditional monitoring focuses on the apps running on VMs. Containers are not VMs. Containers are processes that are running either on a VM or somewhere else that's isolated. You should monitor the application yourself, and I think what's really important is you want to be able to auto-discover metrics for the runtime, the application services, and so forth, because you don't necessarily know what you're always getting inside of that container. So having that auto-discovery is really, really important. Another thing is that you don't want to monitor containers for things like CPU health and alert on CPU of a container going high. Mainly because containers don't last very long. Thank you, Jason, for this diagram. Containers don't last long, and orchestration systems are the ones that should be looking at things like CPU and memory usage and killing off containers and spawning new ones, not your monitoring system. Your orchestrator should be doing that. And what operators and developers want to try and do is focus on is the application actually running the service the way that we want within the timeframes that we want as well. You also want to make sure that your monitoring scales. So in the containerized world or microservices world, you can very quickly go from 10 containers to 20 to 10 to 50 and so forth. So you want to make sure that you take into account those different problems. The other thing that you want to do is also think about monitoring your APIs. This is how a microservices architecture might look. And basically those communication paths become really, really important between those different services. It allows you to catch things like bottlenecks in certain methods, functions, or endpoints if you can get very granular with what API URLs are being hit. You can see more frequently used methods, and it also helps you to trace behavior through those multiple services and multiple systems very quickly as well. And then the other thing is that you want to map your monitoring to your organizational structure. So we mentioned Conway's Law just before lunch as well. I'm sure Conway's Law has come up a lot. But you want to make sure that you're empowering teams to actually set up the monitoring that they need and the alerts and the metrics that they care about versus having that pushed down from a top-level organization as well. So to summarize, containers change how we monitor applications, microservices change how we monitor services. Thank you.